Hello everyone. In this video, we will review how to simulate Verilog modules using a test bench. We will also cover how to use AI to automate the simulation of Verilog modules. So let's start off by discussing how simulation works. In every simulation, we must use a test bench to simulate our Verilog. A test bench is created by adding in a simulation source file. This is how we add in a simulation source file. First, click Add Sources. Then click Add or Create Simulation Sources. Then create the simulation file and name it TB for Test Bench. After adding it in, we can write our test bench in the simulation file. This is where you can find the simulation file. A test bench works by instantiating the module, driving the inputs as registers, and observing the outputs as wires. There are three main ways to simulate a test bench. The first way is to manually drive the inputs with an initial begin block and manually check if the outputs are correct in the waveform. This is the simplest kind of test bench. The second way is to write a task that automates how the inputs are driven and automatically checks the outputs without us needing to manually inspect the waveform. The TCL console will automatically report if a test passed or failed each time. The final way is to have a Python file automate the testing using behavioral verification. Such an approach requires storing the Python program, the test bench, and the source file under testing in a shared directory. This is by far the most powerful way to simulate and determine if a Verilog module is behaviorally correct. In this video, I will only show how to do methods 1 and 2. The third method will have its own video later in this playlist. When simulating a Verilog module, you might want to view signals that are not inputs or outputs. You can easily monitor these internal signals with an assign statement that follows the structure below. So, this here is a Verilog module that lets us multiply two numbers, A and B, to produce a product. The module works by setting the inputs and applying a start pulse to begin the computation. Once the computation is finished, a done pulse indicates that the result is ready. This is the test bench for the source file. The test bench uses the first method, meaning that all of the inputs are manually driven inside of one large initial begin statement. When we run the simulation, we must manually check the waveform to determine whether each test produced the correct result. When you are manually inspecting the waveform, you must set the radix of the signals to be in the right fixed point format. This is another test bench for the same source file. The test bench uses the second method, meaning that a task call is used to automate each test. We can enter the two operands using simple decimal values, and the task will automatically convert them into the correct fixed point representation and drive the inputs for us. When we run the simulation, we can simply look at the TCL console and see whether any of the tests failed. If all of the tests passed, then we know that the module produced the expected results. Suppose we want to monitor the state register. To monitor the state register, we would need an assign statement like this. Then, when we rerun the simulation, we can view the state in the waveform. AI is very useful for automating simulation. It can reliably generate test benches for any one of the three simulation methods previously discussed. For simple test, I recommend using a prompt like the one shown below. So this here is a source file for a Verilog divider. We do not currently have a test bench for it, but we can use AI to generate a good one. First, we need to drag the source file that we want to test into the chat. Then we can give the AI a prompt telling it to create a test bench for the provided source file. A good prompt should say the following. Once you have your prompt, copy and paste it into the chat. After entering the prompt, we need to inspect the generated test bench and make sure it follows the correct structure. In this case, the test bench clearly follows an understandable structure, so we are ready to use it in Vivado. When we run the simulation, we can clearly see in the TCL console if each test passed. Alright, so by now you should understand how a test bench works, how to monitor internal signals, and how to quickly generate a test bench using AI. If you're serious about mastering digital design, then I highly recommend watching the video that covers the third approach. Alright, that's all for this video, and I look forward to seeing you in the next one.